Hello, our today's topic is philosophical and scientific origins of atomic theory. Our journey today is from atoms to plum pudding model, the beginning of atomic models, or to search what matter is made up of. So let's start our journey, but before we start, let's know our itinerary. So this is the timeline of atomic models and also our journey, how we will, what route we are following basically. So it's starting from the very early idea led by Democritus, and we will finally reach Thomson's atomic model via Dalton's atomic theory. So let's begin. Democritus lived during 460 to 370 BC approximately, and he talked about atoms. This idea of matter composed of small particles was led by him. He first talked about this, that matter is made up of indivisible atoms, indivisible particles. He called them atoms. Later, it was protested by Aristotle. Aristotle lived during 384 to 322 BC. He talked about continuous matter. According to him, matter is continuous, made of four elements: earth, water, air, and fire. Both these ideas were purely philosophical ideas. No experiments were done to prove this. Much later, in 1803, Dalton came up with his atomic theory. According to him, atoms are indivisible particles. Atoms of an element are always identical in every aspect. So he agreed with Democritus' idea. According to Dalton, compounds form by atoms combining in fixed ratios. So he explained laws of chemical combination. Then in 1886, discovery of canal ray happened. Goldstein observed canal rays, and he also observed that these were positive rays. Canal rays were observed in discharge tubes in 1886. Later, this experiment was repeated by Rutherford much later, almost about 100 years later. Rutherford confirmed hydrogen nuclei or protons, which were later named protons, via nitrogen bombardment. And these were identified as fundamental positively charged particles. So the impact on atomic model after 1919 was that it established existence of a fundamental positively charged particle that could balance electrons. That also was discovered much later. So in 1886, only presence of some positive ray coming from matter was observed by Goldstein. Then in 1896, almost a decade after that, radioactivity was discovered accidentally by Henry Becquerel. What happened actually during that time, photographic plates were developed by keeping them under sunlight. So in Henry Becquerel's lab, some photographic plates could not be developed that day, and they were kept in dark for the next day so that they could be developed when sun comes up. Next day when lab was opened, it was found that the photographic plates had some darkened spots. So he concluded that some energy was emitted from atoms present in that lab, and those points were, or those darkened spots were because of those radiation. A couple of years later, Marie Curie and Pierre Curie, they discovered polonium and radium. They introduced the concepts of radioactive decay, that matter radiate energy, some matters. They radiate energy and that matter gets reduced in amount because of this decay. And they also introduced concept of half-life, that is, after a certain time, those matter that decay, they become half of the original amount. This time period is known as half-life. And also it was recognized that radioactivity is an atomic property, not chemical. Remember that till that time, nucleus of atom was not identified. So radioactivity was recognized as atomic property, not nuclear property. So the key insight is atoms can spontaneously emit energy and particles, proving that they were not indivisible. Atoms are not indivisible. So Aristotle's idea got discarded with discovery of radioactivity. Then in 1897, a year earlier to discovery of radioactivity, radioactivity though was discovered in 1896, but this concept of decay was introduced in 1898. In between, Thomson came up with his cathode ray experiment in 1897. Discharge tube, the setup was discharge tube with cathode and anode plate, and electric and magnetic fields were applied when rays evolved from cathode and moved towards anode. This led to discovery of electron because it was found that these rays which are emerging from cathode moving towards anode are getting deflected towards positive plate, and they are getting deflected in both electric field and magnetic field, and they are consisting of particulate matter. So these particles were named as electron, and Thomson could measure the charge to mass ratio for these particles. Now, major impact on atomic model. This showed, or this confirmed, that atoms are divisible. So modified Dalton's indivisible atom idea. Also, definitely Aristotle's idea of continuous matter was discarded. Thomson's plum pudding model he gave in 1897 with the discovery of electrons. He proposed electrons are embedded in a positive sphere, that is the atom. So it's just like a plum pudding where these raisins or fruits are like electrons on the base of positively charged sphere. Then Millikan came up with his oil drop experiment, and he concluded about electron charge. Actually, he quantified electron charge. It's between 1909 to 1911. So what did he do? Tiny oil droplets were allowed to pass through perforated plates which were positively charged, and they were allowed to move towards negatively charged plate. And the electric field was applied to this system, and the field was adjusted to balance gravity. It was observed that droplet charges are discrete multiples of a base value. And through this setup, he could measure the elementary charge electron. This base value, multiples of a base value, that base value is actually the elementary charge of electron. So once the charge could be decided, then Definitely, mass also could be calculated based on Thomson's idea of charge to mass ratio. So now atomic model could be improved by knowing electrons charge and mass both. So here our this journey ends. So let us go for lesson check. Which discovery proved Dalton's indivisible atom idea wrong? Let's see the options: proton, neutron, electron, nucleus. The idea is given in the lecture. Go through the lecture once again if you cannot answer. Then answer yourself. Then which experiment disproved Aristotle's continuous matter theory? Definite proportions, cathode ray, gold foil, oil drop. Then in Thomson's model, electrons embedded in a positive sphere. Which observation contradicted this? And then who measured electron charge in the oil drop experiment? So already these are discussed in the lecture. So please go through the lecture again to answer this if you cannot answer now. And after that also, if you have any query, please reach back to us. So thank you. Every atom has a story. Keep exploring. See you in the next video. Thank you again. Bye.